Hello everybody, this is John Blunt, his Good Woodworks in Seattle with our video on wood properties. Very fundamental information which is broadly applicable to all the many design and many engineering decisions when you're planning your woodworking project, and it's very, very useful information to have that can apply to so many things that you may not need to know a specific piece of advice. You figure it out yourself based on this. So we use it in our classes. It's a video we ask our students to watch, and then we'll have a little discussion about it. Okay, on to the wood. It thinks it's alive. It once was alive, and a log comes from a living creature that has a very complex structure to it because it was a living creature. And the complex, it's a composite structure, essentially, where it has different materials of different properties laced together to make something that is much stronger than it would be were it a simple homogeneous material like concrete, which doesn't survive, doesn't stay alive as well. In any case, one of the things that really stands out about wood is that it is a moisture holding phenomenon. It holds a lot of moisture and it swells up. It swells up with moisture and it shrinks as it loses moisture. It initially has moisture that is pulled up from underground through the xylem and phloem tubes, and it's loaded with heavy water, lots of wet water. And so that's called 100% moisture content at that time. As it dries, the seasoning stage of drying, from on the stump at 100% moisture down to maybe 12%, or maybe Arizona, where it's really dry, 7% moisture content, it loses a very large amount of moisture. And it shrinks. And as it shrinks, it's not going to do it equally. It's going to shrink more around the circumference of the tree than it does in diameter or radius. And that is a relationship, pi times diameter equals circumference. If it's not shrinking as much in diameter, the only place where it can give is the degrees of radius. So it's no longer a full circumference. That means it splits. I cut this log to the middle while it was green, and it split in one spot. But if I hadn't done that, it would have been built up, wherever it built up the most stress from differential shrinkage, it would split, and then the stress would be released, and it would build up somewhere else. And the stress would be released again. And it would get splits all over it, partial splits, all over it. Now that can ruin a log as lumber, because even though the log's not going to fall apart, when you cut it up as lumber, many of the boards are going to have splits that go all the way through them, and they fall apart. So they don't do that. The lumber manufacturers keep it wet until they saw it. And if they don't, they're going to wreck their log, and they won't have quality lumber. But once you take the wood out of the tree, that rigid relationship of pi to diameter is no longer locked in by the simple construction of your section of tree. These pieces, as they shrink, can warp instead of splitting. This one cups. This one just plain shrinks. And that depends, what happens to it depends on where it comes out of the log. In these two examples, this one right here, the wood is going to shrink this direction And this piece is going to have symmetry across the center line. And so as it shrinks, it's going to stay flat. It just shrinks equally on both sides. And it actually shrinks less than this one, because this one has more grain that is in the circumferential direction, so it shrinks more than this piece. However, this one doesn't shrink equally on both sides. As you can see, because of the concentric circles, more of the grain on this side is closer to being vertical grain than the grain on this side, which is all pretty, at the surface anyway, pretty close to just a flat line. If it was a large tree, it would almost be a straight line. Okay? So this shrinks more on this side and less on that side. And it's guaranteed that it's going to do what's called cupping, which is shaping it like this across the grain into a cupping shape. Here's a more exaggerated example of that, with the grain more exaggerated. This is all vertical right here. This is, it's more of it is flat grain. So you can predict that by looking at the grain on the end of a board. And you can call it, because you see the shape of the grain, that is a flat grain. You can call this one out and say, well, that's a vertical grain. If it is less than 45 degrees to these flat surfaces, it is a vertical grain board. If it's more than that, like right here, then it is a flat grain board. So now I think I should tell you about how they produce this and how the different ways of milling a board will produce more of this or more of this. Okay, now we're going to show you how we get the wood, these cuts out of the log. The quarter sawing is taking the log and cutting it into quarters first. Then with each quarter, cutting it in this direction across that quarter. And what that does is it produces 100% vertical grain lumber. Even this piece right here, none of these tree rings are more than 45 degrees to the surface. So when they deliberately are trying to produce quarter sawn or vertical grain lumber, they do quarter sawing. Flat sawing is cutting it straight across the whole log, all the way down. And most of what comes out with flat sawing is, or plain sawing, I'm sorry. I really do cross those over. Plain saw is a method, flat grain is an outcome. So plain sawing produces flat grain, and it produces, if this were sliced in this direction, a few vertical grain pieces by plain sawing. And they can be graded out and sold as vertical grain by the sellers, and quarter sawing produces 100% vertical grain. So that's how they do it. And I want to tell you now about what's useful, how they're better used. The plain sawn results in broad flat patterns where this is the same ring of the tree right here, coming in, coming out of the tree here and back in over here. And because it's near the center of the tree, these rings are actually only a tiny bit apart, but you're cutting tangential to them, and you get this broad, considered to be a decorative pattern. It's mountain shapes, cathedral, we call it flame patterns. Those are all terms that are used. And that is going to be on a board that's really wide and not right at the center. It's going to be very much pronounced that the edges of the board have narrow lines, and in the middle you have this beautiful pattern. So that's good for wide pieces. It's good for a certain kind of figure. And it might be applied. If you look at this door right here, you'll see that it's got the patterns you get from plane sawn for the panel. And I don't know if you can see these. I know you can't speak to me, you're not here, but I'm pretending you're here. These might be the shape of the pattern from a plane sawn board cut from near the center of the whole board. And they don't read very well. They look kind of arbitrary and cut up. Whereas the grain is narrow here and running like that, which is what you're going to get with vertical grain. That might be where you would use your piece of vertical grain. And it's also more stable. It doesn't warp as much, it doesn't cup as much, and it doesn't, it's a little bit stronger this way. And so that would be a better choice. You might just be picking your wood out of all plane sawn and choosing the ones that are vertical grain that happen to be in the right part of the tree. So that's one use for it. Vertical grain is deliberately manufactured largely for flooring. The advantage of vertical grain for flooring is that the total expansion contraction is less. When you use flooring and the boards are together like this, they can't expand. They really are prevented from expanding. And what happens is when it gets really wet, and particularly if you get some kind of little bit of flooding going on, the wood is going to expand with so much force and not be able to actually, the whole floor can't grow, so each board is going to get a little internal crushing. When it dries, when that board dries, it will shrink a little bit smaller than it was originally, and you'll get cracks on your floor. If you've done your floor with flat grain lumber, you're going to have more expansion, it's going to be worse cracking. If you do it with flat grain lumber really wide, you're going to have more expansion per board. You're going to get even bigger cracks. If you do it with flat grain lumber, it will cup, and it will work. It will work the nails. They're holding it down a bit and pull them up, and then eventually you'll have a squeaky floor. And if you use quarter sawn, you're going to have narrow pieces. They're going to run individually. They're not going to have that cupping action, making the floor squeak. Very popular use for quarter sawn. Lumber, mostly hard, dense woods like maple, white oak, red oak. So there's nothing wrong with doing a wide floor in your cabin. It's going to have cracks in it. You just have to, it's just best you know what you're going to get. And you might want that. I'm not a purist about any of this. I just want you to know what the properties are. So, okay. So there's a couple of arcane, semi-arcane, specific pieces of information that are good to have before we move on. And that is, how do you deal with plane sawn if you want to make a really big panel and you don't want it to cup? Maybe it's a loose piece. It's a cutting board, a giant cutting board. Maybe it's a farm table. It's going to be really thick, and each piece is going to cup. Well, traditional knowledge says don't just glue them together at random. You take one of these and you orient it that way, the cupping in one direction. Next one over, cupping in the opposite direction. Next one over, cupping in that same direction as the first one. If you don't do that, you'll get this. Cup, 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 all the way across your table, and the whole table will give me a magnified version of a little bit of cupping. This is radical cupping because it's 2x4s. But, and they were dried while they were still pretty wet, and then flattened, or flattened while they were still pretty wet, and then dried. So, so just flipping it over is the key to keeping your counter flat, your tabletop flat, your farm table flat. And another thing to know that comes into play in working with wood and buying wood is the moisture exit. How fast does it come out of that wood? It comes out very slowly, this way. The tree evolved to take water up to the top and to keep it from expanding out. The bark, all those things, keep the moisture in and pull it to the top. After you cut your log, that's a wick. And that's how it gets that water up there, capillary action. Moisture is going to come shooting out of the end at least 10 times the rate of the moisture that's coming out further in out of the sides. What's going to happen? That thing is going to shrink on the end. Right down here, I'm going to draw you a little picture to show you what it does and why you need to be aware of that. And the consequence is mostly that you may not know that you've got some splits in the end of the boards. Okay, so this is looking at the top-down flat face of a board. That board has got a very even moisture content in it all the way down. It just came out of the tree and just is going in the kiln to be dried. Moisture is going to come shooting out the end. They have a partial solution to that. As it comes shooting out the end, it's always going to shrink. You're going to find out that it's dried out right here pretty quickly, well before it's dried out in the middle. Same thing on the other end. It's going to try to shrink like this. It's still swollen up back here. That wick sucked it out. It's going to stress it, and then it's going to split, and then this is going to go right back to where it was. Then each one of these is going to shrink, and it's going to split. Now this one's skinny enough, it might not get enough stress to split, but this happens in the drying process. If you have, at the end of the boards, they have these, the color stuff on the end. That's actually a sealant that they put on there to help slow the moisture coming out. It doesn't cover it completely, but they're drying it pretty quickly and they need to do something. So they put that on the end and that helps. But suppose these are cracked, that's cracked. Then, you know, and it's shaped like this. Well, what's going to happen when it finally catches up back here? The whole board's going to be smaller. And these are going to be able now to close up again. You may have splits in the end of your lumber that you don't even know are there. And then you try to make a board this long, and you got to split halfway down that board, and then it gets drier still, and that split continues and comes apart. So when you're buying lumber, give yourself at least an extra foot on board. If you need a 5-foot board, buy at least a 6-foot piece of rough sawn lumber. That will give you a chance to cut the ends and see if it's got splits. Okay, we've already told you about how wood moves and several of the nuances of how wood moves, except for one other very significant aspect of wood movement, and that is that it doesn't expand with changes in moisture lengthwise or contract lengthwise. That produces a condition which is called grain opposition when you join your wood together. Grain opposition is in the case of two pieces being joined. One of the two pieces having the grain 90 degrees to the other piece. This would be a butt joint. This piece, the wood, is not expanding, contracting in this direction, because it doesn't. This piece, it is expanding and contracting in that direction in opposition to this. So they're fighting each other. If this was just a butt joint with glue, just glued together, it would fail very quickly from the stresses of that fight. So you have to do that sometimes, and there are ways to deal with that issue. You can't escape the need to do this sometimes. So let's go back to our door over here for a little further explanation, okay? You need the strength of this. You do not have strength across the grain. You need the inherent straightness, greater straightness of this. Cupping in a board is much more pronounced than bow lengthwise. So you don't want that to get a big cup. Your door will be extremely warped. If the grain is this way, in this piece, it will break. But you have to have pieces wrapped around. The reason you need to wrap around a frame, put a frame around, is because you need the strength in this direction and then turn it this direction and then turn it again this direction. And then what fills it in, called a panel, that one usually will have the grain vertical, and it is not locked in place. It's allowed to expand and contract. And so it's in a groove, basically. You know, since you need that strength, this is the one place in woodworking where you have to have the grain opposition to achieve a strong frame. So the way they make that last a long time is by doing a joinery. These two pieces, this weak joint that would fail if it was just a butt joint, can be strengthened with joinery. It might be what's called a loose tenon, and also the modern version is called a domino joint, where inside the joint a bridging pin runs across. It has grain running this way, it's strong, goes into both of them, gets glued. That enhances the life of this particular joint, which has grain opposition, greatly. And then there are additional joints, many more, but that's outside the scope of this video. We'll have one on joinery in the future. So you do that. But there's plenty that you don't do. Plenty of things that you do not want to do. You keep this small and you join it to overcome the limitations of a joint with grain opposition. Otherwise, you need to avoid having grain opposition. There are solutions for the problems that you can have. Here's a problem. I'm going to slide a solution right underneath it. Here's a problem. It doesn't have this kind of solution. It doesn't have a solution that has to do with solid wood, plywood. That's a solution for this one. So, here you see a joint. It's in grain opposition here. And somebody made the mistake of gluing this on right here and pinning it here with dowels. Dowels have no give. So this piece that's locked here and here cannot expand and contract, and it will do something about that. These 2 points And the fact that this is not moving with moisture, if it's shrinking, this represents what would happen if this were put together fairly damp and then allowed to dry. It can't shrink toward, the pins can't shrink toward the center. There's two of them, so it splits in order to be able to shrink toward the pins. You can do that on a very small scale because the total amount of movement is so much less. You can mitigate the problem by putting a very thorough finish over the surface of it. Epoxy, in particular, blocks moisture transmission to a very high degree. So the piece may never reach the level of the changes in the atmosphere. So it goes from damp, it only gets to 30% there before it's already drying up again. It gets back. So there's less movement total. Those are things you can do. You can do this, but not on a grand scale. This would be disastrous if you had a solid wood table this wide and you put a cleat across the end. It's going to split in multiple places as it fights the lock that you've put on it. Here's a solution. Produces a very similar appearance. I'm going to hold this close so you can see the end there. You see the taper in there? And dovetail is what that's called, and it's a sliding dovetail is the name of the joint. It's not glued. It has to be very carefully machined because the wedging action of these two tapers has to be just the right dimension so that it forces that joint down, but you can actually slide it in the end. So we're going to show you that it is not glued, but it does hold it flat because the superior strength of this piece here prevents that piece from cupping, holds it flat. And this piece does not split because it's free to move back and forth within this joint, which is usually pinned in the center to keep everything centered as it expands and contracts. It has limitations. It looks like this. It's called a breadboard end, and that's what it's used for, or cutting board, which may get wet, may want to cup very easily because you've been doing something damp on the front, mixing dough on it. Moisture goes in one side, it tries to cup, this prevents it. And then eventually it'll flatten out anyway, but this is a temporary solution to that. So now this one, there's nothing much you can do. It represents a piece of solid wood, grain running this way, that would have been put together when it was really dry out, and then the rains to come, and it expands. It pushes this with it, this piece of trim with it. It pushes this piece of trim with it, and it simply opens up that miter corner. This is not very strong. It may be pinned on or something, but it's going to break that glue line quickly. The glue just doesn't have the elasticity to contend with that much movement, and it'll break. So this, you cannot directly solve that with a trick joint, but you can solve it with plywood. Plywood is made out of layers of veneer. Veneer is simply thin wood. Maybe at 1/4 inch you might still call it veneer. Finished veneer is only 32nd. Plywood core veneers are 1/8 or sometimes even thicker. So these are about the thickness of plywood core veneers. It would have any variety of finished veneers on the outside. I built it for demo's sake. Plywood is put together by taking veneer and alternating the direction of the plies of veneer each time, and gluing the entire face very soundly. We've already gone over the fact that this is not elastic. It doesn't stretch much, doesn't compress much, whereas with the grain, or across the grain rather, it compresses a lot more easily and stretches and actually splits apart much more easily. So if you make a strong enough and permanent enough bond right here, then this will actually prevent, it will hold, this grain this way will hold this grain from expanding, while this grain on this one this way, the one underneath, will prevent this one from expanding that way. You cannot do that with just 2 plies, however, or with an odd number of plies. If my finger represents a grain, and these fingers represent grain going the other way, it's really easy for the expansion of this grain to just bend the other grain backwards. Not if there's another set of grain on the other side pushing against it, expanding and expanding. That would stay stable. 5 plies, fine. 3 plies, minimum. It's not plywood without 3. 5, 7, 9 ply. More plies means more stable, means usually thinner plies. And so it actually works. This grain is not going to move across the grain. This is not going to move across the grain, neither is this. And so that means you have a solution to this proposition. And we have done that on multiple times. We once built a beautiful veneered desktop with Madrona burl in little square patterns, Madrona burl veneer on top of a plywood core with this massive mahogany molding wrapped around it, shaped like that, nice detail like that. It's still there, no problems. It is not an issue with plywood to do that, or to do a simpler opposition joint like that, because it's already taken care of by the multiple plies within the veneer. One other way you can deal with expansion and contraction is with a door. You've seen that over here, this little detail, which shows that this joint right here is in opposition, but we keep it small. And we've done the joinery, that interlocking joint that you might call cope and stick joint. These two are mirrors and match each other. This cut on this and that one, they interlock and fit, and you can easily add a dowel to it. Just one is better than 2. Think that one through. And that will last a very long time, but this one is too big. There's too much movement in that. So a panel door puts a panel in a groove that allows room for expansion, either expansion or contraction, while it's still held in place by being inside a groove. And that's how this works to enclose a field with solid wood that will be very soundly flat and long-lasting. All right. We're ready now for the last section of this body of knowledge. And that is moving into a little more practical realms, drawn on what I just taught you about wood. What I just taught you is something you might be able to guess what I'm about to say from what you heard before, is that wood ain't flat. It bent and everything, and if you have a really long piece of wood, you can't fit a flat board inside it. So then they don't try. When they pre-process your lumber, it comes out of the kiln bent. There's an odd one or two that don't have much curve in them, and those are kind of prizes if you need a long flat board, and you pick them first. But I'm going to have to draw some pictures here to show you where or why, to make it a little more clear, why, what you do and why you do it, and what you buy. I'm going to give you a picture, kind of fattened up a little bit for clarity's sake right here, of the edge. No, I'm going to draw it 3D. This is a long curved board. That's the edge of the board. It's got a lot of bow to it. And that's what it looks like. It did that in the kiln, did that a little when you cut it and all. So it's a little out of scale, and that's deliberate. But say that's about 10 feet long. And that's how much curvature you have, over 10 feet, and the whole distance that it rises and falls through that curve can be shown with this line right here. That's indicating a flat plane running underneath this. At this length, if you want to make a flat board inside this long board, you would have to flatten this face with a machine called a jointer. Check out that video. And if this is a line showing what the bottom of this board looks like after you flatten it. And you can see that right here, when you reach this point, you still have your full thickness. That would be, in the best case, 15/16 if it's a 4/4 board. I will explain that in a minute. So you buy it thicker than what your target dimension is, and you then dress it down flat. And you have to do that because they can't give it to you flat. If they did make this board flat, and on here, and then they wanted to make it down to 3/4 from the full inch or 15/16, guess what? By the time they get here, the board is run so far out of the plane that they no longer can get their thickness out of that board from here to here. So they don't try it. Instead, they run that curved board through the planer. You can watch that video too. You go through the planer, and what the planer does, it has a roller and it has a cutter head, cuts it off, and it has another roller, and all it does, thing goes through the machine like that. It gets bent down and planed so that it's thinner. It's thinner, and it is a predicted thickness, whatever you set the planer at, but it springs right back. So what you get is a smooth board that's shaped like this, that's thinner, because if they tried to do it this way, they'd throw away half their lumber. So professionals, particularly furniture makers, cabinet makers, and people who make doors and the like, they buy their lumber oversized, and then they cut it shorter. Knowing what their parts are going to be, they can cut it shorter, and then they will be able to fit a 3/4 inch flat board inside that 1 inch rough board that has the curve in it. If they do need a long board that's as flat as you can get it, they're going to pick a board first, the long ones first, and be able to get a decent length out of it with and at the thickness they desire. So when you're picking it out to do this flattening process, you pick the long ones first and you sight them by eye to see if they're the closest ones to straight, because out of the tree it's a crapshoot. Some of them bow a lot, some of them bow less. So we want to talk a little bit more about the nomenclature of wood. So you know what you're buying. Speak the language, because there is an industry language that the professionals and the wholesalers and almost all the retailers understand. And they refer to lumber in a thickness of lumber by quarters. I don't know where that came from, but it's an old standard. So instead of saying it's a 1 inch board, they'll say it's 4/4. Instead of saying it's 2 inch board, they'll say it's 8/4. Okay, start with that. If you ask for 8/4, you then have to qualify it and say what kind of 8/4. Because a rough sawn board at 8/4 is 2 inches with a fair amount of variation, mostly wider. And a hit and miss board is the same board after it goes through the planer, 1/16 thinner than the nominal dimension, which is a quarter, which means 2 inches. So you'll buy that hit and miss board at 1 15/16. If it was a 4-quarter hit and miss board, it would be 15/16. That gives you room, additional remaining material in it to cut it shorter, then fit inside the board, the curved board, a flat board of the dimension that you desire. As long as the curve is not too great and the length is, curve or the length are not so great that the board just runs out and you don't have any wood to work with. So we almost always will dress our lumber. That means make it flat, straight, and two-dimension, doing the longest ones first, because you got to pick them out. They got to need ones that are closer to flat already. So the industry does that. Now, the industry also has a standard for the dimension that the rough sawn lumber is destined to be when they call it completely finished. One of the words is surfaced 4 sides. It's been all cleaned up, all 4 sides, face, back, edge, edge, and to a standardized dimension. It's called dimensional lumber. It can be called S4S, surface 4 sides, or it can be more casually called dress lumber. I sometimes call them store boards. They're not flat because they would lose so much money. They don't know what lengths you need. So you don't buy that lumber, and when your project requires flatness, and you don't always need it to be flat, depends on what you're making. So once they've done that, a 4-quarter board is destined to be 3/4, finished lumber. A 8-quarter board, bigger jump, they're going to go to 1.5. And then they have increments for width, so what you call a 4-inch board is actually 3.5. An 8-inch board is actually 7.25 wide. Those are store boards, and they're called dimensional lumber, and they're not flat. You might get lucky and pick one because the tree was, wasn't traumatized. So that's our process. We buy it wide, we cut it shorter, and then we flatten it, and then we're done. There's a little bit more to it that's not in the scope of the wood properties. The most important thing is know how to buy your lumber, so you don't come to the shop with 3/4-inch thick boards that you just, you think they're flat because you didn't learn that. It's hard to see it sometimes, but it makes it significant, even though it's hard to see when you're trying to do joints, when you're trying to cut 90-degree corners. You do need to flatten it, so you buy it thicker. Hit and miss is the best because it's been regularized in thickness, so there's less work involved, and because you can see what it looks like. The rough sawn surface really obscures the appearance of the wood. You can't be sure what it's going to look like. Much better idea. There would be spots on the hit and miss where the board was a little thinner than 15/16, and that'll be rough. But you can see most of the board, and the rough part is the miss part of hit and miss. So I think that's it. I do have one other resource. I'll mention it, but if this thing ages, it might not be there when you look for it. But we have a link on our shop rentals page to it's a button, not down too far, that says about buying solid lumber. It goes into a little more detail than what I give in this video, just alerting you. And if you want to come in and use the shop and you want to start off, don't run off and buy lumber with thinking that part through. And I can always advise people who come in that as to what they should buy and clarify for you. So that's pretty much concludes this video, and I thank you very much. Come see us at any time. Come join us. You can take classes, and you can also do rentals and be mentored. And I'll teach you similar to the way I'm teaching you right now, but maybe smaller bites. So thank you very much. Hope to see you here.